Hello, Mr. Westwater here to take you through another video on factorising quadratics. So leading on from previous videos, I'm hoping that you understand how to factorise a general quadratic when it's in this form, where we've got x squared plus or minus something x plus or minus something else. So for example, x squared minus 3x plus 2, I don't know, something like that. I'm hoping that by now you have a good understanding of how to factorise this. It will go to two brackets, and the key thing is that we're looking for two numbers which multiply to c but will add to b. Okay, so we'd have x and x, okay, and then two factors of c. So in this example above, it's going to be 1 and 2. Well, actually, it's not going to be plus 1 and plus 2. It would be minus 1 and minus 2. Okay? Because these two factors of this will now sum to the middle term. So that's hopefully what you already know. Let's just analyse this a little bit more. Okay? So if we have, there are four different sort of cases we could have. If we've got two pluses, then we know that it's going to come from two positive numbers, okay? Because two positive numbers will make a positive outcome, and it can't be two negatives, because two negatives will not sum to a positive. Two negatives would sum to a negative, which is actually our second case. So if we have two brackets, or sorry, a quadratic, and the final term is positive, then we can say the sign will be the same, okay, in our quadratic. But if our middle term is positive, then these will both be positive, and if our middle term is negative, our coefficient of x is negative, then our brackets will both be negative. Okay, so I guess you could say our brackets will match the coefficient of x, this thing in the middle. Okay, and if our final term is negative, then it doesn't really matter what this sign is, because we know that this is going to come from two brackets where we've got a positive number times a negative number. Okay, so it's going to be something like that. The only thing this tells us is that when we sum the result, that will end up with a positive. So I guess you could say in this case, then we'll have the larger number would be positive if the net result is positive, and it would be a larger negative number if the net result is negative. Okay, so this is stuff you should already know, or maybe some of the links that you're trying to see, I guess. What I'm going to look at now is what happens when it doesn't look like it's an easily factorizable quadratic, but actually it's not as bad as you may think. Okay, and the key thing is, and the thing that should be at the forefront of your mind all the time, is the first thing that you ever saw when it came to factorising. Now, if you remember back to maybe last year or the year before when you did factorising for the first time, we didn't have quadratics, we didn't have two brackets. All we had was one bracket, something like this. Yes? And in this case, we didn't look for, products and sums. All we looked for is there any common factor that is in all of the terms? And even if you see a quadratic, that should be your first thought. Are there any common factors in this expression? Okay, so what I'm going to do is I'm going to take you through a few examples. I've written 4 down, but I think there's probably a couple more we should go through as well, just to take you through this as a concept. Okay, so let's have a look at this term. So on the face of it, it doesn't look too nice, but actually, if we look at this carefully, you can see that all of my terms here are even. So all of them can be divided by 2. So the first thing I'm going to do is take a factor of 2 out of everything. So this would actually be x squared, 8x, and 12. Okay, and so now I can just focus on this quadratic, and it's not as scary. There's not a number in front of x squared anymore. So I'm going to put it into 2 brackets. I'll leave the 2 on the outside, and we're looking for 2 numbers, multiply to 12, sum to 8. That's going to be 6 and 2. Okay, both positive, so I know I've got 2 positive numbers in here, 6, 2, x, x. Okay, let's have a look at the next one. So here again, I've got a horrible number in front of x squared, but actually, again, if I look at this as a whole, I notice that 3 goes into everything. Okay, so I can take out a common factor of 3. This will be x squared minus 10x and 21. And so again, I'm looking for 2 numbers which multiply to 21 but sum to 10. Now, as this is positive, the 21 is positive, I know the signs are going to be the same in the brackets. Okay, 3 will be on the outside because it's on the outside over here. And as this is negative, both signs will have to be negative. Okay, so I can already half answer the question before I've really thought about it. So I'm looking for 2 numbers which multiply to 21, sum to minus 10. That's going to be 7 and 3. Okay. Third example. Again, we have a horrible looking quadratic, but here I hope you can see everything is divisible by 5. So first port of call is to divide everything through by 5 and take that factor of 5 out. Okay, so again, leave the 5 outside your brackets. Oops. And we know that this is going to be a positive times a negative because I've got a negative at the end. So plus, minus, and again this is going to be x times x. We're looking for 2 numbers which multiply to 24, but I guess have a difference of 2 as one's positive and one's negative. 6 and 4 comes to mind. Now I want the result to be positive, so the larger number 6 is going to have to be positive. Okay. And final one of the examples that I've written down. We have a common factor of 4 through everything. Okay, so I can take 4 out, and this would leave me with x squared minus 5x. And what does this go into? 80 would be 20, so I think we've got 24 again. Yeah. So again, 4 goes outside my 2 brackets. This last term is negative, so again I know it's coming from a positive times a negative number, x times x. Okay, and we've got 2 numbers which multiply to 24 but sum to minus 5, or I guess as one's positive and one's negative, they'll have a difference of 5. This time 8 and 3 come to mind. I want the result to be negative though, so the larger number is going to be negative. Okay, so that's a quick introduction to this. There's a couple more examples I'd like to show you though. So if you just bear with me for 1 second. Let's say we've got 16, or yeah, let's say 16 plus 6x minus x squared. Now, you may say that actually there's no common factor here. There's nothing that goes into it, but this isn't my normal quadratic because I've got a minus x squared. So the thing I'm going to do here is I'm going to take out a factor of minus 1. If I put minus 1 outside the brackets, I would now have plus x squared, and I'm going to just rewrite it in descending powers of x, so that this is the normal layout of a quadratic, with x squared first, then x, then your constant at the end. So x squared minus 6x minus 16. Okay, and now this is a bit more familiar. It's a more regular, sort of more usual, more familiar format. So I'm going to put it into two brackets, x, and again minus 1 on the outside. I know one's going to have to be positive and one's going to have to be negative. We're looking for two numbers which multiply to minus 16, have a difference of 6. That's going to be 8 and 2. We want the result to be negative, so the larger number is going to be negative. Okay. I hope you found that helpful. Stay tuned for more videos.